Okay. This is term 2, week 6, math CA. Okay, we have a few pieces of questions, and I think they're in the quiz. Anyways, to combat global carbon emissions, engineers are seeking innovative solutions to incorporate renewable energy into modern systems and reduce reliance on fossil fuels. One proposal involves using high altitude wind turbines attached to tethered balloons to generate electricity for ground facilities. One advantage of using a tethered balloon is that it flies at a height of 200 meters. There, the wind speed is approximately 30% higher than at ground level. If the ground level wind speed is measured to be 20 kilometers an hour, at what approximate speed does the wind blow at 200 meters above the ground? So, obviously, if it's 30% higher, then all we have to do is just do 0.3 times the ground level, which is 6. So it's higher by 6. And then how much is the ground level? 20. So you just add 20, 26. If you want to do other way is just do 1.3 times 20 and you get 26. Whatever you want, they all work. If the tether is pulling the turbine at an angle of 40 degrees and the vertical height is 200 meters, approximately how long is the tether? This is a simple trigonometric question. You have an angle, you have the opposite side, and they want the hypotenuse. So you have the angle, you have the opposite side, you have hypotenuse. Obviously, we're going to use sine of the angle because sine of any alpha is equal to opposite over hypotenuse, right? So sine of 40 is equal to 200 over the hypotenuse. How do you find the hypotenuse? You remember, if you have a variable in the denominator of the fraction, you could just swap it with the other number. So it's going to be h is equal to 200 divided by sine 40. You're gonna get, okay, I'm saying why am I getting 268? My calculator is on radians, so let me repeat this. You can get 311. Okay. Question 2, this is actual math now. The third term of the arithmetic progression is 12 and the 10th term is 33. What is the 35th term of this progression? So let's go back to our formulas in arithmetic and geometric sequences. For any arithmetic progression, the nth term is equal to dn plus b, where remember d is equal to the constant difference and b is equal to a1 minus d, grade 10 formulas. For any arithmetic progression, the sum is equal to n over 2 a1 plus an. Another formula would be Sn is equal to n over 2 brackets 2a1 plus n minus 1 d. This comes from the fact that over here, actually, any an is equal to a1, right? a1 plus n minus 1. Sorry, my n minus 1 d. This is another formula for an, but I like using this one. This is the same as this, but just a bit simplified. Okay. Anyway, so these are the arithmetic progression formulas. For the geometric progression, any term, the nth term in the geometric progression is equal to g1 times r to the power of n minus 1, where r is equal to gn over gn minus 1. For example, g2 over g1, right? So the second term over the first term gets you r. The sum of terms in a geometric progression is equal to, it's a1
I'm saying with the decimal.
1 minus r to the power of n over 1 minus r, and that's your sum. If it was summed to infinity, it would be equal to a1 over 1 minus r. Okay, or let's say g1 instead of a, right? Because we're using geometric progression, but it's better to say g. This is sum of n to infinity. Okay, so these are our rules, and you can use them here and every other question. Okay, for this one over here, the third term of an arithmetic progression is 12, and the 10th is 33. What is the 35th term of this progression? So there's a few ways you can do this, but the first thing I want to find is, in my opinion, when working with arithmetic progressions, this magic d. You can't work without having the d. Okay, well, no, not like that, huh? Not like that. But the d, yeah, the constant difference. I need the d. Okay. So there's one formula I actually left out, and that's an minus am is equal to n minus m d. Okay, so I actually have here, I'm going to use this formula. So using an minus am equals n minus md. So people are going to say, Tabalit, how am I gonna, how do I know to use this? I think, whenever you have two terms that are far away from each other and you want to find the constant difference, you use these, because this formula shows any two terms in the progression, regardless of how far they are from each other. You can find the constant difference if you have those two terms. Anyway, so the third term is 12. So we're talking about a3, right? Or let's not start with a3. Let's start with a10, because a10 is bigger. I don't want to get a negative answer. So we're going to say a10 minus a3 is equal to n minus m. What's my n? 10. N is the place value of where it is in the progression, and also m. Okay, so 10th term, so 10 is my n. Third term, so m is 3. 10 minus 3 d. What's a10? We know it's 33. What's a3? We know it's 12. And you can solve this as a normal equation. You're going to get 33 minus 12, that's 21, equals 7d. So d is equal to 3. What is the 35th term of this progression? Now we know the constant difference. Okay, to find the 35th term, you can use a35 is equal to dn plus b. You can use this adi. You could use a35 is equal to a1 plus n minus 1 d. You could use that adi. But there's two problems with both of these, and the problem is you don't have a1. Okay, you can find it, of course you can find it, but you're gonna have to use an extra step. So actually using this formula, I can actually find a35, knowing that I have d now. So I want to find a35. Right, you can use a3 or a10, it doesn't matter. We'll use just a10. Okay, using this formula again, I can find what a35 is equal to. So I know that a35 minus a10, using this formula, is equal to n minus md, so 35 minus 10 times d. Let's start substituting. We're trying to find a35, so we're going to keep it as our unknown. A10 we know is 33, 35 minus 10 is 25, and we know that the constant difference is 3. So you're going to get 75 plus 3, you're going to get 108. So a35 is equal to 108. You can use my method of solving. Many people have different ways of solving. You can use whatever you want. What is the common ratio of a geometric progression in which the second term is 6, so g2 is 6, and the fifth term is negative 162. So another formula, again, I'm sorry I left it out, it's actually over here. So this works, right, to find r, but also let's say the two terms they gave you aren't right after each other. So you could say r to the power of n minus m is equal to gn over gm. Okay, so why is this useful? Think about it like this: you have a, then b, then c, then d, then e, and everyone here is being multiplied by the common ratio r, right? So e divided by a would actually be equal to how many r's? 1, 2, 3, 4. R to the power of 4. And e is the fifth value over here. A is the first value. So it's actually the same as just saying, let's call this g, and let's say g5 is e, right? g1 is a. It's equal to r to the power of 4, and 4 is actually just 5 minus 1. So r to the power of 5 minus 1. So you see how the formula works? That's just an example of how it works. So why is this important? Because sometimes you're going to need the common ratio and the two terms given aren't right after each other. Okay, so when they're not right after each other, you use this. R to the power of n minus m equals gn over gm. So over here, they gave me the fifth term and the second term. So they gave me g2 and they gave me g5. So if I want to find r, I'm going to do g5 over g2. But since, remember, we're doing n minus m, right? R to the power of n minus m. Since they're not after each other, I have to do n minus m. So what's 5 minus 2? 3. So r cubed is equal to g5 over g2, and we can just do it on the calculator. I do our integral calculators allowed. No integral, okay. So you can do shift solve. But anyway, g5 is negative 162. G2 is 6. If you do it on your calculator, 729, negative 162 divided by 6, you get negative 27. So r cubed is equal to negative 27, and the cube root of negative 27 is obviously negative 3. Is my mic working? Yes, it is. Okay. Question 4. The sum of the first 4 terms of the geometric progression, this is 11 over k. What is the value of k? So over here, the sum of a geometric progression. Obviously, you can just add them, right? I mean, I guess that's the first thing someone would think of over here. But let's teach you the proper way. Let's say instead of 5 they said 10, and I don't think anyone's gonna go keep on multiplying by the common ratio 10 times. So for that reason, I'm gonna use the formula way, which is the sum of any geometric progression, okay, is equal to a1 1 minus r to the power of n over 1 minus r. Since we're speaking about the first 5 terms, we're going to do the sum of the first 5 terms is equal to a1 1 minus r to the power of 5 over 1 minus r. Let's solve now. We need r, right? How do you find r? Since we have the first and second terms, we have 2 consecutive terms. R can easily be found when you have 2 consecutive terms in a geometric progression. You can just divide them by each other. So negative 2 over 4 is equal to negative half. And you can check this, by the way. Every term is being multiplied by negative half. 4 times negative half is negative 2. Negative 2 times negative half is 1. 1 times negative half is negative half, and so on and so forth. So the ratio r is negative half. In other words, we can just do say negative 0.5 because I don't like working with fractions, especially when you have a lot of fractions already. A1 is 4 times open brackets. We have a fraction 1 minus r to the power of 5, so 0.5 to the power of 5 over 1 minus 0.5 equal, you get the whoa. Hold up. Okay, my dumbass over here, in the ratio, it's negative 0.5. I don't know why I put positive. So 1 minus r, so 1 minus 0.5. So over here. And 11 over 4. Perfect. Question 5. What is the sum to infinity of a geometric series if its first term is 48 and its second term is 36? Sum to infinity. S infinity is equal to G1, 1 minus, sum to infinity, it's G1 over 1 minus R. That's it. G1 is 48. 1 minus R. What's R? We have the first and second term. So we have 2 consecutive terms. To find R, you can just do G2 divided by G1. So 36 divided by 48. And it's actually 12, it's divided by 12, 3 over 4. So you can say 3 over 4 or 0.75. Let's do this on our calculator. You're gonna get 0.25 when you subtract the denominator, so you get 192. Okay, and some people they get confused when I do this, so let me just put it for you like this. You'll understand. Question 6. Okay, this is a nice question. We had it last year as well. I like it. It needs a bit of thinking. Okay, a ball is dropped and bounces such that the height of each bounce is 50% of the height of the previous bounce. So you're multiplying by 0.5 each time. It's half every time. Okay, so r is equal to 0.5. The first bounce is 10 feet. So they gave us what? G1 is equal to 10. The height the ball bounces on the 10th bounce is how much? So we have a geometric progression. Obviously, we are asked to find G10. We know Gn is equal to G1 times r to the power of n minus 1. So what's G1? 10. R 0.5. We're talking about the 10th bounce. So n minus 1. So 10 minus 1. Let's see. 10 times 0.5 to the 9. And you get 5 over 256. The total vertical distance traveled by the ball from when it first hits the ground until it hits the ground on the 10th bounce is what? So now they're asking us for what? The sum, the total distance, the sum. So we're looking at the sum of the numbers up until 10, right? So what's the formula? It's G1 times 1 minus r to the power of n over 1 minus r. Let's start substituting. So 10 times 1 minus 0.5 to the power of, since we're looking until the 10th bounce, so it's to the power of 10 over 1 minus, again, the ratio, which is 0.5. Do this on your calculator. 10 times and 10 times open bracket 1 minus 0.5 to the power of 10 over 1 minus 0.5, and you get the answer. Oh. Okay, okay. Why is it over 128? Okay, okay. I just realized now. You have to multiply this answer by 2. Okay. People are gonna be like, "What? Why?" Okay. Here's the thing. When you're bouncing a ball, okay, this is why I told you I like this question, because there's a bit of thinking involved. So you're standing here. Oh, you throw the ball. It goes up, like we said, 5 over 256 feet. Right? What are they saying? It's the distance traveled. Are they asking how high did it go? No. So this ball that's now 5 over 256 high is gonna have to go down also 5 over 256, and it does this for every bounce. So you can think of it as every bounce times 2. So in general, the sum you get, just multiply it by 2, and you get over 128. Okay. No matter how many times the ball bounces, the total vertical distance traveled by the ball from when it first hits the ground will not be greater than 1. So now we're talking about the infinite, the most you can get, right? So in general, we're talking here about the sum to infinity. When you're saying the total vertical bounce, no matter how many times, so we're saying infinite number of times. Okay, so sum to infinity is always g1 over 1 minus r. So it's going to be 10 over 1 minus what's the ratio? We said it's 0.5, yeah? So 1 minus 0.5, and you're going to get 20 over here. But why is it 40? Because again, we're saying the distance traveled. So when you're talking about the distance traveled by a bouncing ball, you always multiply by 2, and you get 40. Okay? Okay, question 7. Consider the sequence un, which is defined recursively, that any nth term un, it's equal to 4 un minus 1 plus un minus 2. So 4 times the term before it plus the term that's 2 terms before it. So this is what we call a recursive definition, and a recursive definition depends on the one before it, which is pretty self-explanatory. It's recursive, okay? So if I tell you an is equal to an minus 1 plus 5, this is a recursive definition because I included the one before it. Anyways, they give us u1 is 2, u2 is 5, what's the value of u4? Whenever you have recursive definitions, you have to work your way up, okay? You can't just directly find u4, because u4 would be equal to 4 times u3 plus u2, right? Because I'm just substituting n as 4, right? So what's the problem here is I don't have u3. So this is what I mean when I say you have to work your way up. So u3 would be equal to 4u2 plus u1, which I have both of these terms. So therefore I can say 4 times 5 plus 2, which is 22. So u3 is equal to 22, and now I can find u4. I shouldn't have deleted it, but u4 would be equal to 4 times u3 plus u2. And substitute your values, 4 times 22 plus 5, so you're gonna get 93. Okay? Question 8. an is an arithmetic progression which a24 minus a8 equals 176. What is the common difference of this progression? So they gave us an minus am, and they asking us for the common difference. So this, you're gonna, for all of these questions, you're gonna have to use a formula, but you need to know when do I use which formula. In this case, this looks like the formula an minus am equals n minus md, and even they're saying what's the common difference. So let's figure this out. They said that an minus am in this case is equal to 176. So I can change all of this by 176 equals n minus md, 24 and 8. So my n value is 24 and my m value is 8. So 24 minus 8 d. So 176 is equal to 16d, and then you just divide. You should get 11. Yes, you get 11. Question 9. The first term of an arithmetic progression is negative 4, and the 14th term is 61. So they gave us a1, and they gave us a14. Okay, what's the sum of the first 20 terms? So they want sum of the first 20 terms. You know, the sum of the first 20 terms is equal to n over 2 a1 plus an, right? Or you can use the formula n over, whoa, I'm getting a random number called. Okay, S20 also would be n over 2 2a1 plus n minus 1 d. So you can use this and find a20 because we're looking for the 20 terms, or you can use this without finding a20, which in my opinion this is easier. So I'm going to use this. N over 2 would just be 20 over 2 because n is 20, right? We're looking for the 20th terms. 2a1, so 2 times negative 4 plus n minus 1d. Again, 20 minus 1 times d. So the problem here is we need d. So how do we find d? Like I told you in other questions, you can't work without having the d. Again, I don't mean it like that, if you understand. Anyway, let me continue explaining and do my job. You need to have the common difference, okay? I'm gonna stop calling it the d. How do you find the common difference? By using, when you have two terms, we have a1 and a14. When you have two terms that are not consecutively after each other, you use this formula like we used earlier to find the common difference. an minus am, we're looking at the larger term, so 61 minus am, which is negative 4, equals n minus md, so 14 minus 1 d. Okay, so you're gonna get 65 is equal to 15d. And this is a bit of a weird one because equals 13. How do I get 15? 14 minus 1 is 13. How do I get 15? I'm saying something's wrong. So 13d, and d should be equal to 5. Okay, when you divide these. Anyways, so now you know that d is 5, so you can substitute it over here. So you get s20 is equal to 10, negative 8, plus 19 times 5. I'm just simplifying everything, huh? 20 over 2 is 10, 2 times minus 4 minus 8, 20 minus 1, 19. Anyways, so you're going to get S20 is equal to 10. I'm just doing it, I don't want to do it on a calculator, I'm too lazy. 195, so negative 8 plus 95 is going to be 90 minus 3, 87. So you're going to get S20 is equal to 870. You could have just done this all on the calculator, would have saved you time, but because on PC it takes me time to open and type the number. If I just do it in my head, it's easier. Given the sum of infinity of a geometric progression is 32. So they gave you s infinity is 32, and its common ratio is r is equal to 3 over 4. What is the value of the first term a1? So what do we know about the infinite sum? We know that sum infinity is equal to g1 over 1 minus r. Type. They gave us r, they gave us the sum, and they want us to find g1. So g1 is actually just equal to the sum of infinity times 1 minus r, right? If you just cross multiply. So g1 would be equal to the sum of infinity, which is given in the question, is 32, times 1 minus r being 3 over 4. You can just do this on your calculator, and you should get 8. Question 11. These questions are very easy. What's the common ratio of the geometric progression? Okay, wow. To find the common ratio given two consecutive terms, you can just divide the second term by the first term, and you get negative 2. Question 12. Given geometric progression with g, with g1 equal 3 and common ratio 2. What is g5? Remember, in any geometric progression, the nth term is always g1 times r to the power of n minus 1. So gn, g5 in this case would be equal to g1, 3 times r 2 to the power of n minus 1. So 5 minus 1. So you're going to get 3 times 16, 48. Do it on your calculator. Huh? Then we have a pizza question. A giant watermill wheel is installed along a riverbank to harness energy. See the diagram below. The wheel has an external diameter of 76 meters and its highest point is 81 meters above the riverbed, and the wheel rotates in the direction shown by arrows. The letter C in the diagram indicates the center of the wheel. How many meters above the riverbed is the point C? So obviously they told us that the diameter over here is 76, and this one here is 5, which is why it's total 81. So we want to know how far is C. Obviously, since C is the center, this over here is the radius, which is equal to the diameter over 2, which is just equal to 76 over 2. So you get 43. But they're saying how far away from the riverbed. Oh, from the riverbed? That's wrong. Should be 48. Let me make sure of this. Wait. Okay, guys. So, again, as usual, My dumbass does not know how to do 76 divided by 2. So let me repeat this. So now we agreed that this is r, which is half of the diameter 76, so it's 76 over 2, which is actually 38. ما بعرف من وين جبت 43. So if this is 38 and you have 5 meters above the riverbed, so 38 plus 5, so point C is 43 meters above. Anyways, the wheel rotates at a constant speed, completing one full rotation in 20 minutes. Emily watches the wheel starting from the lowest point marked as P. Where will Emily's observation point be after 15 minutes? So هيدي P after 15 minutes, where will it be? So they told us that the full rotation is 20 minutes, and we waited 15 minutes. So how many rotations will you do in 15 minutes? 15 out of 20 is 3 out of 4. So you could say 75% of a rotation. So whatever you want, and in my opinion, this is what I do. If it's 3 out of 4, so obviously I have 4 points. 1, 2, 3. Sorry. This is the first point. Over here, you go quarter rotation, 2 quarters of a rotation, 3 quarters of rotation, full rotation, and you're back at B. And we're saying 3 quarters. So you go 1, 2, 3. So where do you end up? At T. That's literally it. These questions cannot get easier. So we're done here, but they mentioned pages 1 to 3. So I'm just going to make sure that there's nothing that I missed. If not, let me check. I'll see now. Okay, so there's nothing here. So we're done. Thank you so much for watching, and good luck in your CA.